Okay, so now let's get into our examples. Okay, so here is example number one. So what I want us to do on example number one is, again, looking at our general form, so bx plus c, and then this is our vertex form or standard form, x minus h squared plus k. So our first one that I want us to do is I want us to write this equation. So f of x is equal to 2x squared plus 8x plus 7. So I want us to write in standard form. All right. So again, this is our standard form, and then this is our general form. So I'm going to show us two different ways that we can approach this problem. Okay. So one of the first ways that we can do is using our equation, where we have to figure out what our vertex is by finding this formula. Or the second way what we can do is the second way that we can do is there it is changing it using our completing the square. So I'm going to show this first by completing the square. So complete the square. Okay, so we should probably remember this from our integrated 3 classes. So when we complete the square, what we're doing is we're first going to take away the 2, so then we'll just be left with x squared and then plus 4x and then plus something and then plus 7. So what we're trying to do is we're trying to complete the square that makes this become a perfect square. Right? So I'm going to put x squared here, which means that this will be x and x. 4, so it needs to be separated into 2 equal parts. So this will be 2 and 2, so plus 2 plus 2, which means that 4 is what goes in here, right? So in order to complete the square, this is going to be 4. Okay, but what I have to do is I have to add, if I add a 4 inside the parentheses, I want to make sure that I keep it the same, so I have to add the opposite. Now, if I think about this, is not really just 4. This is really 2x squared, 8x, so that means that this is really 8, which means that this is actually negative 8. Okay, so if we kind of just go off to the side really fast, 2x squared plus 8x plus 8, and then plus 7 plus negative 8. Notice that these two guys are going to cancel out, and notice that the 7 is just going to be what we have left over. Okay, so we want to make sure that we do this appropriately. Okay, by always adding the opposite to what we've already added into the parentheses. Okay, so then I have a 2, and then x squared plus 4x plus 4. This is really x plus 2, x plus 2. So this just becomes x plus 2 squared, and then 7 plus negative 8 gives me minus 1. So f of x is equal to this guy right here. Notice that this 2 is our a value. Notice that that 2 is exactly the a value. But in this form, what I know is I know my vertex. So my vertex would be negative 2, comma negative 1. So that is definitely one way that we can approach this problem. All right, the second way is by using our vertex formula. So the vertex formula, so negative b over 2a, and then f of negative b over 2a inside here, and knowing that this is really h and k, and then we'll be plugging in what we know. All right, so let's do it exactly the same way. So, so this will be x is equal to negative b, so negative 8 all over 2 times 2, so negative 8 all over 4, which gives you negative 2. Notice negative 2, negative 2. So what do I have to do to find my y value? Right, I have to go f of negative 2, substitution. So negative 2 squared plus 8 times negative 2 plus 7. So this gives you negative 2 times 4, which is 8. And then this is minus 16. So 8 minus 16 and then plus 7. So 8 minus 16 is negative 8, and negative 8 plus 7 gives me negative 1. So when I look at my look at my vertex form, let me write this again one more time, right? My A has to be exactly the same as before. So if we come back up here, so the A and the A, so that would be your 2. So here's 2, X, and then your H, again, this is your H, minus a negative 2, and then plus negative 1. So negative and a negative cancel each other out, leaving you with that positive 2. So again, two different ways to approach the same problem. Okay, so let's go ahead and let's try one more out. Right. So same problem. So write in standard form this problem. So f of x is equal to x squared minus 10x plus 25. So go ahead, pause the video. It's a little bit easier, and you're just writing it in standard form, so that way we can identify the vertex. And however you want to do it is up to you. All right, coming back from a paused video. So I'm going to do this by completing the square on this one. So trying to figure out what I have to add, and then again the negative version of this. So if I set this up, I don't have to factor anything else out. So x squared half of 10 is 5. So again, this gives you x and x, negative 5, negative 5. So this will be a positive 25. So I'm going to add a negative 25 over here. So, and then this will be a 25 over here. There's no reason to multiply, so it's exactly the same. So this guy is just f of x is equal to my a value, which is 1, and then x minus 5 squared. 25 plus negative 25 is 0, so we don't need to add anything else. So identify the vertex. The vertex should be 5, 0. So again, if you didn't do it this way and you did it the other way, x is equal to, you would have plugged this in negative 10 all over 2 times 1, so 10 over 2, which gives you 5, and then plugged it in right here. So 5 squared, not equal to, my bad. And then minus 10 times 5 plus 25. This would have given you the big 0. And then we plug it into our general form. So again, two different things that we are asking for. Write in standard form and identify the vertex. Okay. So our next example, what we want to do now, we've kind of figured out how to identify the vertex, write it in standard form. So let's get a little bit harder. So this will be example 3. So we are going to find the vertex. I want us to find the axis of symmetry, which I am going to call AOS, axis of symmetry. Right? And then I also want us to find x-intercepts, and I want us to find the y-intercepts. So that's what's going to happen on this problem. Okay, so let's go ahead and try this first one out. So this will be y is equal to x squared minus 6x plus 9. So if you want to go ahead, you want to pause the video right now and try to do this, that's great. All right, so coming back from a paused video, unless you did not pause the video, I'm going to go ahead and find these guys first. So y-intercept, let's find the y-intercept first. So y-intercept, we remembered that the y-intercept just means that I'm plugging in a 0 in, and really it's just your c value. So your y-intercept should be 0, 9. That's it, that's our y-intercept. Didn't need to do very much. So y-intercept, excellent. X-intercept. So in order to figure out this x-intercept, I'm going to go ahead and see if it's factorable. So let's go ahead and realize, so if I multiply x squared by 9, so this will be 9x squared and negative 6x. Are there two numbers that will multiply to a positive but add to a negative? I believe they are two numbers, so negative 3x and negative 3x. That should seem to work. So I'm going to go ahead and factor this. So x squared, negative 3x, and a 9. So x minus 3, and then x minus 3. So what I want to do is I can say x minus 3 and x minus 3, and I would set these equal to 0. So if I set x minus 3 equal to 0, I get x is equal to 3, which is nice. If I set the other one, x minus 3 is equal to 0, I'm also going to x is equal to 3. So my x-intercept is 3, 0. Axis of symmetry, so AOS, or AOS, so negative b over 2a, that is our formula. So negative b, so negative and a negative 6, all over 2 times 1. So 6 over 2 gives us 3. X is equal to 3. So notice the axis of symmetry is x is equal to 3. X-intercept is x is equal to 3, which means our vertex is also going to be 3, 0. If we plug in 3, so this will be 3 squared minus 6 times 3 plus 9. So 9 minus 18 plus 9 gives us 0. So it's definitely an easy problem right here. Let's try another one. So why don't you go ahead and pause the video and try this one out. So again, so this would be example, the last one was example 3, perfect. So this is example 4. Again, I want us to find the vertex, axis of symmetry, y-intercept, x-intercepts. So y is equal to, let's go negative x squared minus 4x plus 21. All right, so go ahead and pause that video right now. All right, if you're coming back, here are our 4 things that we are going to find. All right, so y-intercept, that is pretty straightforward. If I plug a 0 into everything, this should be 0, 21. Let's quickly find our x-intercept. So again, if we multiply these numbers, so I'm going to get negative 21 and then a negative 4. So I believe the numbers should be 7 and 3, but let's make the 7 negative. Right, so x squared, negative x squared. This will be a negative 7x and a 3x and a 21. So let's put the negative here. So this will be a 7, and let's put a 3 here. Perfect. So it'll be x plus 7, negative x plus 3 equal to 0. So if I set this first thing equal, I'm going to get negative 7, negative x plus 3 equal to 0. So this should be negative x is equal to a negative 3. So x is equal to positive 3. So we have negative 7, 0, and 3, 0. Axis of symmetry. So x is equal to negative b. So negative, negative 4. All over 2 times a. So 4 over negative 2 gives us negative 2. So then this will be y is equal to, so x is equal to negative 2. And then this will be negative and a negative 2 minus 4 times negative 2 plus 21. So negative and negative turn positive, but this will be still negative 4 plus 8 plus 21. So negative 4 plus 8 is 4. 4 plus 21 should be 25. So our vertex is negative 2, 25.